Hello everybody, I'm Dan. Welcome to my Java tutorial series. Throughout my tutorials I will teach you Java using just Notepad and the command prompt. The order in which my tutorials are organized on both my website at javacjava.com and my YouTube playlist is designed to maximize learning by building on concepts from prior tutorials. This tutorial is about the equals method and the equality operator, and specifically how they relate to the integer class. I'm going to open up my web browser to my website, javacjava.com, select menu, and then Java OOP tutorials. I'm going to scroll all the way down here to the integer equals. Okay, so basically here's the signature for the equals method, right? You pass it in an object, and basically it has to be compatible with the integer type here. And autoboxing can change a lot of that stuff for us there. So, and then it will return either true or false, the Boolean value, and its public method. So the equals method compares the value of the parameter to the value of the current integer object. If the value is the same, the method will return true, otherwise it will return false. So for example, here's what we have here. In this statement, I got a ref1 variable of integer type, and I'm setting that equal to a reference to a new integer, right, with a value, new integer instance with a value of 419. So that'll create a new integer instance, right, on the heap there. And then I've got in this next statement, basically, I'm setting ref2 in a reference variable 2 equal to an integer type, and setting that equal to a new instance of another integer, and I'm passing it, the other constructor type here of string 419. Now both of these will be separate objects on the memory heap because of the new operator, right? And heap memory, I should say, but that will basically do that, okay? And then on the third variable down here, ref3, integer type, I'm setting that equal to 419. Now autoboxing will go ahead and change this into basically an integer instance of an integer on there, right? And so by calling the equals method, right, we can check to see if the value of, like for example, ref1, and then invoking the equals method and passing it in ref2, that's basically saying is 419 equal to 419, right? And that will return back true. Same thing here, ref1, does that equal the value of ref1, invoking the equals method, does that equal, the value of ref3, 419 equals 419? Yeah, that's true too. We can also say ref1 equals, and then literally put in like an integer literal right here. Autoboxing will convert this into an object type, right? Specifically integer object type. Autoboxing will do that, so we can compare a basic integer literal there too, and that'll return back true. And of course, just passing in a value that doesn't even equal that returns false. So that's basically the equals method there, and I'll go over some stuff like that. Now I want to talk about something called the integer cache. It is very easy to confuse the functionality of the double equal equality operator and the equals method, right? The double equals equality operator has some super strange behavior relating to the integer class. Recall that a reference variable holds a reference to an object located on the heap memory. Normally, the double equality operator will determine if a reference variable refers to the same object on the heap, right? So here I've got ref1, setting that equal to a new integer instance or object on the heap. Its value has 419. Ref2 here, right? New integer object. Its value has 419. And then I'm setting ref3 equal to ref1. So if we say, okay, ref1, is that equal to ref2? That's false, because they point to separate instances, objects on the heap. Ref1, is that equal to ref3? That's true, because they point to the same object on the heap. Okay, now there's a special feature called integer cache that exists to save memory and improve performance. The integer cache works like this. First, it checks for an integer instance with the same value in the cache. If one does exist, it just returns that reference. Otherwise, a new integer instance will be created in the cache, and that reference is returned. Now here's the first catch on the cache. By default, it only applies to values from -127 to +127. Okay, so if we declare an integer variable I2, we initialize that to a new integer type holding integer instance holding the value of 127, and then I2 holding the value of 127, and we say, okay, is I1 equal to I2? And that is true because they point to the same instance on the heap, because 127 is within this range I set up here, right? Which is basically the minimum and maximum value of a byte. Now, we come down here and basically say I3 equals 128, I4 equals 128, I3, is that equal to I4? That's false because they point to separate instances on the heap, right? So as long as when you create a variable, right, if its value is 127 to negative 127, it'll go ahead and create it in the integer cache, right, and recycle that particular value there. So you have an integer object somewhere in the integer cache holding 127. And same here, right? Here, these are going to be two separate objects. So we're instances of the integer objects, right? And so when we use the equality operator, no, they point to two different places in memory of the heap, okay? So now here is the second catch on the cache. Integer caching only applies to autoboxing. Integer objects will not be cached when created using a constructor. Okay, so if I do I5 equals new integer 127, I6 equals new integer 127, and I say is I5 equal to I6, that's false. They each point to separate instance objects on the heap. Okay, so autoboxing up here, which essentially creates, it almost does what this does, but when it goes through the autoboxing method, it doesn't. It goes and checks the integer cache. When we specifically specify new integer here, right, it literally creates new integer object on the heap. So we have two integer instances on the heap in this particular case, and they're not pointing to the same instance on the heap, right? Same thing here. It doesn't even matter about the 127, 128. When we use integer I7, new integer 128, I8, new integer 128, passing it, we're invoking the constructor when we do this here. And we say I7, is I7 equal to I8? No, that's false because they do it there. They point to separate instances on the heap. Okay, so now if you aren't thoroughly confused by now, then that's a good thing. But if you are, we'll go down here, do some coding. I'll go through some other stuff here, and you might have to watch this video a couple times to get it. And by the way, you're going to want to make for sure that you want to let you watch my integer class tutorial prior to this, and you also want to make sure you watch my wrapper classes and autoboxing tutorials as well. So let's come down here, highlight this, Control C to copy, right click or select copy. Let's move the browser off screen. Now I've got a shortcut to the command prompt on my desktop, but if you don't, you can create one by right clicking, selecting new, and then shortcut. I'm going to type in CMD next and finish, and that's just that easy. Let's go and open this up. First thing we do is type in javac. We want to make sure the Java runtime is installed properly there, and the javac is the Java compiler. You should see all this stuff scroll by. If you get an error message, then you're going to want to watch my tutorial on installing the Java Development Kit. Make sure you get that installed and configured properly before continuing. CLS to clear the screen, CD space /, CD is short for change directory, and / tells it to go to the root. I'm going to make a directory called Java, and I already have it, but if you don't, it'll go ahead and create one for you there. And I'm going to change directories to the Java folder, and I'm going to make another directory here, and I'm just going to call this integer equals. Change directory to integer equals folder, and I'm going to notepad integer equals.java. Okay, integer equals.java is going to be the name of my source code file. Okay, Control V to paste, or right click and select paste. All right, let's go ahead and save this. And the first thing I'm going to, and a lot of this is very similar to what I was talking about before there. I'm going to show you a whole bunch of little interesting things about this here. And don't feel bad if this video is thoroughly confusing, because this is a complicated subject when you're talking to double equals. So I'm going to go ahead and clear the screen. javac, let's compile this, and Java to run the integer equal, invoke the integer equals class. Okay. So basically, let's check out the first ones here, right? I did exactly what I originally talked about using and this first section here is just all about using the equals method, right? New integer 419, created through a constructor, passing an integer literal, passing, and then another one here, ref2, passing 419 as a string, right, created through the constructor. And then just an auto boxing ref3, setting it equal to an integer literal 419, which will auto box that into a ref3, into an integer instance, and ref3 will point to that, of course. So the first thing is ref1. If we say ref1, or run the statement ref1 equals the equals method ref2, right? That's going to return back true because it's checking the value of it. It's saying, okay, is the value of ref1 equal to the value of ref2? Not the reference value, but the actual value that the object that ref1 and ref2 are pointing to, which is 419 and 419. You can also think of it as a state, right? The state that ref1 points to is 419, and the state that ref2 points to is 419, right? So the same thing with ref1 dot equals, to invoke the equals method, ref3, that's true. 419 equals 419. You can even pass it in the equals method right here, 419, that equals that, right? That's true, and then that equals false. Let's come down to the next section where I have basically started to use the double equals all the way down for the rest of the stuff there. So in this first one here, R1 is a new integer, 419, R2 is a new integer, 419, and R3 equals R1, right? So when we basically evaluate the expression R1 equals R2, right, that is going to return back false because they're both pointing to different instances on the memory heap that just happen to hold the same value, right? So, if we say, okay, is R1 equal to R3? Well, yes, because R1 and R3 are pointing to the same instance. I should say referring, not pointing, but anyway, it's essentially the same. Java's a little sensitive when they say pointing because that's an old C++ term there. So, but anyway, they're both referring to the same instance of that object, right? This one right up here. So that is true. Fairly simple on that. Okay, now let's come down here and start to talk about the, this is where I start to introduce you to examples of the integer cache, okay? So I1 and I2, right? 127, 127. This is creating instance of, this first one creates a new instance in the integer cache because it's within the range, the negative 120, I think 128, 127. Is that what I had up there? Yeah, negative 127 to 127 there. Might actually be negative 128. I might have that incorrectly, but anyway, whatever. So this is at the higher end of that. So it says, okay, when I auto box this 127 into a new integer instance, I'm going to go ahead and put it in the integer cache, right? And then when I run this statement right here, oh, hey, I2, right? I'm going to go ahead and check the cache, see if the integer cache, because this is 127, right? It's within the bounds of the integer cache. I'm going to go ahead and check to see if one exists already, and if it does, I'll go ahead and just sign its reference there, right? So it says, oh, okay, I see this instance right here in the integer cache. I'm going to go ahead and set its reference equal to that too, automatically, right? So when we evaluate the expression I1 is it equal to I2, right? That comes out over here. That's true, right? Now, 128, it says, oh, okay, when I auto box 128, this is outside the bounds. I don't even care. I'm just going to create a whole new integer instance on the heap. Same thing with I4, oh, 128, that's outside of the bounds of the integer cache. I'm going to go ahead and just create a new instance of an integer on the heap, right? So these two are pointing to two separate instances. So when I when we evaluate the expression I3, is that equal to I4? That is going to turn out false, okay? Now the second part of the gotchas there is that the integer cache only applies to auto boxing. So when we specifically say new integer 127, new integer 127, this creates two new objects. There is no auto boxing going on here, right? So I5 and I6, when we check for if they're using the equality operator, which says, you know, does I5, does it refer to the same object as I6? No, that is false, right? Same thing I just threw in the 7 and 8 to the 127, 128 to kind of keep this, you know, themed along with the same sort of school of thought as that, but same thing. When you use new, creates a new object. New creates a new object. So they're referring to two separate objects when we evaluate the expression. Is I7 equal, is the reference to I7 equal to the reference to I8? No, they're pointing to two different things, so that's false. Okay, now let's come down here and look at some tricky stuff here, right? We can evaluate stuff like, for example, if we evaluate the expression I1, right? Now I1 is equal to 127, right? So if we evaluate the expression I1 equals to, is I1 equal to 127? Well, that's going to come back true. If we evaluate the expression I3, I3 is 128. So I3, is that equal to 128? Well, that's going to come back true. Now, I'm going to do one more thing here before I explain what's going on. So I'm declaring this integer tricky, right, to 8675309, or 09 if you want to do it. I'll just, probably should beaten this dead horse into the ground with that example number there. But anyway, so we know what happens is this is auto-boxed, right? So that creates a new tricky, but it's outside of the range of the 127 here, right? So this is, so the auto-boxing just simply creates a new instance of an integer holding this value on the memory heap, right? So if we say, if we evaluate the expression tricky equals, and then we just compare it against this string literal, right? That's going to come out to true. Okay, so what is actually happening here when we have a, we're using the equality operator and we have a integer literal in there, right? What it does is it unautoboxes this. So for example, unautobox I1, right? And basically say, okay, is a, and when I say unautobox, if you haven't watched my autobox and unautoboxing thing, an unautobox will convert or return a primitive int value from an object. So when this unautoboxes I1, it returns back a primitive int 127, and we check for the primitive int 127 equals 127, right? Because the equality operator is the way you test for equality when you're talking primitive values, right? So that returns back true. So it doesn't matter how large the number here. This will unautobox I3, which will return a primitive 100 value of 128. We're checking that if that's equal. So this will always come back true. Same thing with tricky. It'll unautobox the tricky instance, right, and return 8675309 and check to see if that's equal to 8675309. 09, but anyway, and that of course will return back true. Okay, so you may or may not be thoroughly confused at this point in time. It is complicated. I'm going to go ahead and close out of this and get rid of that and leave you with some final thoughts on this one here. So the equals method, right, is fairly simple to understand. Now, however, the double equal equality operator is quite complicated, and I really highly recommend against using it in any circumstances. And there was one other thing I'm going to show you here real quick there. I'm going to bring this back up there. I have this on my tutorial there too. We can pass, let's see, I'm going to go ahead and notepad. So this value I talked about, negative 127 to positive 127, we can actually change that value using some command line arguments here. So what I'm going to do is come down here and I'm going to just basically going to clear the screen here. So on my tutorial page here, right, I've got for the stuff where you compile it here, I've got where you can run it like this, or we can pass it in this particular parameter right here, or argument, right, when running the Java virtual machine. And so this will actually say, okay, any numbers from 256 can go ahead and we'll set our max cache up to 256. So if we invoke, well, let me just go ahead and run this here real quick without that, right? All right, so in this particular case right here, right, which is I1 and I2, right, and then I3 and I4, because 128, when this is autobox, it's outside of that range there, we can pass a Java. So just note right here, I1 is true, I1 equals I2, or is equal to, operator here, that's true, and then I3 double equals I4, that's equal to false. So if we go ahead and pass it this parameter there, and then the name of the class, right, integer equals. Okay, now you can see I3 equals double equals I4 is equal to true, and that's because we told the auto box cache max to go ahead and increase to the number 256, right? So 128 is now within that number, and that works out great. If I were to do something like, for example, make this 260, right? That will then be outside of that cached range there. Let's go ahead and save this here, recompile it. Right, then we're back to false, right? So we could then, of course, keep increasing this up here. Let's just do something like 512, right? Now we're back to true. Okay, so that's the results of your program can really be manipulated from the command line when you're running the Java virtual machine. So that is I'm gonna go ahead and close out of that, get rid of that. So that's one of the reasons why another one of the reasons why I highly recommend against using it in any and all circumstances. You know, if you do have some sort of circumstance that you're going to be using the double equality operator, you really got to know what you're doing and what you're up against there. So that concludes this tutorial. Thanks for watching.